So next up we have the wheel holder that's going to be mounted to the Arbor on the Arbor press, and we have to drill a couple of 1024 through holes, drill and tap some 6mm by 1mm threaded metric screws, and the reason for that is because the wheels are metric. They come from Italy, I believe. And so I'm just finding my zeros here and setting my DRO, and we will be good to go. So we're going to through drill those two and drill and tap these two. Then we're going to try and do all the contours of the wheel holder. So we're going to drill and tap the first, or just drill the first hole. So I'm going to spot it, and I put a template on here so that when I cut out the sides, it'll be more obvious what has to go, because it's a kind of a complicated piece. So just so you know that the template is not spot on alignment wise, but the holes are being placed accurately. Excellent. So now we can move on to removing the meat of the material from both sides here and the center section, and then by hand we're going to remove the material on the circular portions. Next up, we're going to remove the material here that goes up to the horizontal tangent. I made the width of the part exactly the horizontal tangent of the circles for the mounting plate, and they're not critical values. Their size is completely arbitrary. It's to support the wheels behind them. So we're going to remove this material. Again, not critical, but we're going to try for precision only because it's good practice. So I'm just spending a lot more time doing everything than I need to, going for higher levels of precision. By the way, I am aware of the fact that a radius in the corner is stronger than an abrupt 90, but I don't think we're going to have to worry about forces here being exceptional because we're just cutting glass. Last pass, second side. Getting the final depth here. Okay. So we need to take this out, we need to deburr it, and then we'll mill the final side. Next up, we need to mill the slot here. And we need to go in depth-wise 300 thousandths, and we're going to use the width of the cutter. There's a 1/4 inch cutter. The total width is 300 thousandths, so we're going to go plus or minus 25 thousandths once we're at depth. So we're going to start just by nipping off a little bit here. Let's see if this is too aggressive. It's 50 thousandths. No problem. Okay, now we're going to go 25 thousandths to one side. And maybe we'll nip at it here. We'll do 10 thousandths passes. And we're done. All right, so I need to make another template because the coolant I used dissolved the lightweight glue that I used to hold the template on. So I'm going to put the template on, and I'm just going to remove the excess material here and make it roughly round, which is what I'm shooting for. If we needed precision, we use something like the rotary table, but there's absolutely nothing like this. At this point, it's mostly aesthetics and clearance, so I will bring you right back. Next up, we're going to cut the V groove in the, I guess you call it sort of a platen for the press. And I've got it sitting here on a V block at 45 degrees. And trying to figure out the depth and the center position can be kind of challenging. You'd have to do a little geometry, or if you're lucky, you do CAD. And I used the edge point here to move in a certain distance, 0.7779, and you know, I didn't keep this edge perfectly sharp. So if this was an ultra precise thing, this would be a hard way to do it, because if you relieve this edge and you don't make them all exactly the same, then you're gonna have a problem. So probably would have to do a fixed radius if that was the case, but it's not, fortunately. So we're gonna go a ½ inch deep, and we're gonna do the full width of the cutter. Actually, yeah, it should be just the full width of the cutter should just fit. Anyways, let's just give this guy a shot and see how it works out. So we're just going to take a little bit of material at first. It won't be the whole cutter biting, so it's 25 thousandths depth. Could have gone more. I just wanted to get my head set on what I'm looking at here. All right, that's pretty good. Nice clean edge. All right. I don't know if this is too much. This is 100 thousandths depth of cut. For this small an engagement, it's probably okay, but I probably can't get away with that big a bite in future cuts. That might be a little bit much. Next time around, we're going to reduce that. We're doing the last passes in 2 passes. Only 5 thousandths depth of cut. And that's it. So we have our V block mounted upside down, and we're finding our 0 coordinates. There we go. For this corner, and I got to 0 the DRO, then move over 100 thousandths, and then we're going to drill and tap the mounting holes, and it's mounting from the bottom, so we're going to make them blind. Sorry about that. Here they are here, and I show them all the way through here because originally I was going to go all the way through, but I think it'll look nicer if they're blind. So we're going to do that. We're going to set our 0 depth for the tip. Since this is a blind hole, I'm going to clear out the hole very carefully, and then we'll tap. All right, so we're going to try something I've never tried before. We're going to power tap a blind hole. I set my 0 on the DRO, so I went 725 thousandths down, so around 680 I'm going to stop. Oh, he's stuck anyways. Well, let's clean out the chips and we'll see if we can get the last bit. We stopped at about 450 thousandths. So what I like to do in this sort of case is I like to pre-start it so that it won't accidentally make new holes. So alright, that finishes the second hole. So now we've got to drill the base to match so we can mount this plate. And this holds the glass, this V-groove aligns the glass for the cutter and also supports it underneath the cutter for the cut. Also, just a side note, you might have not have noticed, but I had to use my thin parallels on this because you can see how close the holes are to the side of the material, and the 1/8 inch parallels just missed clearing. Getting yourself a set of these, they're fairly inexpensive and incredibly useful, especially in situations like this. Although you've got to be careful when placing your part that you're actually on the flat part of the surface, since it's so narrow, rather than just behind it, which can happen. So you got to pay a lot of attention, but they're very useful to have. So holding the Arbor press upside down is a bit of a challenge on this mill. I don't have the extension riser on the head, so I'm pretty much maxed out at the bottom here. And what I did was I used a level to get the base level. It's only going through about 1/4 inch of material here, so I really don't have to worry about the hole not being straight for long distances. So I got it fairly close with the level and a parallel across the 2 feet, which aren't perfect either. They rock a little bit, so there is no good reference surface on the bottom. I used a grinding vise to hold one edge on this side, and then if we swing over here, the base of the Arbor press down here is on the mill table, and I've got another grinding vise in my main mill vise holding the fin on the back. And there's not going to be a lot of tool pressure here because all we're doing is cutting 2 1/4 inch, 1/4 through holes. But I just needed it stable enough to make the drilling operation happen. So let me go get the drill and we'll proceed. Well, I got a reference off of these 2 surfaces that I cut earlier, because the spacing in here of where the drill bit is going to go is referenced to these 2. That's why I did that, because otherwise this casting is so uneven that you'd have nowhere to choose as a reference point to measure off of. So I need consistent measuring points. Also, the thickness of the casting is different, so I spaced it. The hole spacing is weird, and the reason for that is because this thickness is much thinner than this thickness, and I wanted it centered as much as possible in the bottom because there's a lot of curved portion on the bottom, so I wanted the screws to lie as flat as possible. So anyways, you can see inside the casting how rough it is. So this is going to be an interesting little drilling session here. And first we're going to get our reference locations, and then we're going to drill. Even going to the center was not enough to get a flat spot on the casting, so we're going to take this end mill and we're going to go in and flatten it off so that I have a chance at actually drilling this 1/4 inch hole. So as long as we're at it, we're going to go over to the other location and just clean it up too, and then I'll bring you right back. All right, I know it's hard for you to see in there. Let's see if I can squeeze you in a little closer. I've actually got to work here too, but this is the farthest drilling point. You can't actually see where it lands. You might find it hard to believe that that whole massive setup was just to accurately place these 2 holes. Machining this side, flipping it upside down, pre-machining the bottom, and then finally drilling the holes. All of that was just to locate these 2 holes relative to the plunger on the Arbor press. And that's one of the things I really enjoy about machining, is the problem solving on sometimes these really weird work holding issues. So anyways, that was fun. I think we're at the point now where we can reassemble most of the parts here. The V-groove I took over to the surface grinder and cleaned it up. I need to practice on the surface grinder, and I love the way it looks when it's done. I didn't take it down that far, so there's a little bit of, I don't know, little pockets that didn't get cleaned up from when it was being cut out, but I think it's pretty good. So I think we should start by attaching this guy on here, and see if you can see that. I left these screws the holes a little bit oversized. That way there'd be some slop, and you might think that'd be a bad idea. for the Arbor, but in fact what I wanted is the screws to only hold this against the back plate there, and that this would slide up flush against the Arbor itself, which I did surface grind, so that makes a nice connection there. So got a couple of screws here somewhere. There they are. So let's attach this guy. Okay, let's pop open one of the cutting wheel sets. Attach the cutting wheels because I'm going to measure off those. So there's two ways they can be mounted. I set this up so that the sharp edge here, see they're beveled just on one side, flat on the other. The sharp edge is going to be on the outside to come up against this guy right here. They don't need to rotate. At least I don't think they do. If they do, I've got provisions in the design to change that later. But in the meantime, I think they can be locked in one position and work pretty effectively. It's pretty warm and humid out, although I gotta say for Southern California in mid-July, this isn't anywhere near as hot as it can be. It easily could be over 100, but at least 90s, but it's actually like 84 outside. The humidity is pretty high though. All right, so the spacing of these two guys I based on the thinnest material you want to, cut in there, and as you can see, it'll go pretty small before you hit the gap. So then this guy is going to go in here, and just to protect it in case I drop it, we'll set it on some cloth here because I need to be able to put the spacer in. So this is one of those deals where you gotta bury this plate in here that I didn't replace. I think if this was mine, I would consider doing it only because it bugs me that it's so crappy. Slide that back a little bit for you. I've loosened up the setting screws, which I've replaced, by the way. All four of the setting screws, the ones that came with it, two of them were bent, so they didn't move very gently. And I figured if she ever needed to adjust this, a Phillips would be easier for her to come across than having two wrenches. So also, that's the metric screws I had in this size. I guess I shouldn't discount that small fact. So right now it's not engaged at all. And it's interesting, as you tighten this, it goes a little bit diagonal and goes over the side. So we're going to leave these loose for now because this spacing for these two guys right here, which I also replaced these screws, that spacing over there will set the position of the cutters relative to this block down below. If I need to take it off again and trim it up, I left material so I could do that as well. So let's start with it over to the right and see how that works out. Oh, kind of forgot to put this guy in too. There you go. Didn't even line these two screws up with each other. They didn't line much up. It's almost like they had a hand drill and they just drilled these things at random. It's pretty bizarre. Okay, so let's lock the Arbor in place here. Everything's got to be a different size Allen. All right, now I am going to flip this on its side. Hopefully it won't block your view, so I can mount this guy. This guy's going to go right here. And And what happened to the 2 screws I had for that? So that's tightening the last of those 2/4 20 by 1 screws, and the amount of length material I left underneath there was adequate. So next one we do is lower this down. Oh wow, that's interesting. It's way off. I'm gonna have to remove a bunch of material off this base piece. I must have missed. Oh, you know what? I might have flipped this 180. I bet that's what I did. Let me take that off and try it the other way. It appears that I screwed up, and better than too much than too little material. I'm not quite sure how I did that. I based the depth exactly on this edge here on the inside rather than the outside here. I am not quite sure how I did that because I was thinking about that anyways. So I'm going to take this over to the bandsaw, cut off some material, and then take it over to the mill and clean it up so that these can go right down that face, and we'll be right back. Well, it took a couple iterations of removing material off here because I tried to walk it in, and I had to remove some material off the end here to make clearance for the screw heads. If I'd done this in 3D CAD, that would have been obvious, but you can see now it clears, comes to a stop, and so now I just need something to catch the canes as they come off, and I think in order to do that we're gonna have to try test cutting one. I've never done this before, but this is a really out of round shaped piece, so it might be a good test. Oh, actually that's working great. Yeah, it's actually cutting really nicely. Oh yeah, not much force at all. So that actually worked pretty well. As far as something to capture it, they're not flying too far, and it's not making too many extra pieces of glass. So I'm gonna have to see what other options I can come up with. I did get this adhesive scale so that she would have a way of measuring how far she's cutting, so she could make duplicate pieces out of this thing. But yeah, this is turning out better than I thought. It looks like the next step's gonna be making a holder for this guy, and I think we can probably keep it in place with a rubber band. So we just need to head over to the mill and work on some aluminum and see if we can make a bracket. I think hold it in with rubber bands will be a good idea. We'll see. We'll give it a play it by ear, and then we can mount this is an adhesive scale. We can put it inside, and we can calibrate our cut length so that she can get her cut length fairly accurate if she wants to make them repeatable. Here we are at the final design, and the bracket I made on the side, I accidentally got one extra screw hole. I was going to make it adjustable, but I decided against it. Just put a couple pins in the side, made a relief for the tubing to go in, and used some rubber bands just to hold it in place. Then I cut off part of the material so that it would clear the cutter, and we are good to go. It now keeps the pieces of glass, the Murinne pieces contained inside the acrylic. If you put a bag out here, you can catch the ones that get a little more aggressive flying out. All in all, I think the project turned out really good, and I think the client will be really happy. Spare set of cutters, got the original wheel, the original bolts that one of which is bent. I'll give them back. She can have the new bolts I put in there for her, and I'll make a couple more of these in case they break. And if she wants, she can add this guy in there, and she'll know exactly how long the pieces she's cutting are. It's just self-adhesive, so she can stick it to the bottom if she so likes. So we'll talk to the client about that. All right, so here's some examples of some glass getting cut. I think the project was successful. Thanks for watching. Hope you find it useful. Hope to see you next time.